Hi everyone, it's Mrs Jennison here and I'm an Associate Director for Outward Grange Academies Trust. Welcome to our next lesson. Today we are looking at crude oil, hydrocarbons and alkanes. It would be really useful if you had a pen and a piece of paper so that you could complete the activities as we work through the video. Our challenge for today is to be able to give features of hydrocarbons and describe how to name and draw hydrocarbons. Our aspire is to be able to explain how the properties of alkanes are linked to their chain lengths. So first, a little bit of context. On the screen is an infographic. The orange bits are areas where there is known sources of crude oil. What I'd like you to do is I'd like you to use the information in the diagram to explain why Qatar is one of the richest countries in the world. Okay, so hopefully you linked the source of crude oil to the economy. Qatar is the richest country in Southwest Asia. It has a booming economy thanks to natural gases and oil reserves that are found within the territory of that country. And it did top the list of richest country in the world in 2016 with a pretty high GDP. So, why is oil so expensive and so valuable to us? Well, it's all due to what we can make from that oil and what it is a source of to our countries, and we will look at that throughout this topic. So first, I'm going to insert a video that talks about crude oil.
In this video, you will learn how fractional distillation separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil. That is oil that has been taken directly out of the ground, either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are useful as fuels, and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be a viscous, dark-coloured tar-like consistency, and the different fractions of hydrocarbons must be separated by fractional distillation for them to be useful. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of hydrocarbons with different chain lengths, some being short molecules and some being very long. Intermolecular forces act between molecules, and the longer the molecule, the greater the intermolecular force. As you can see here, the small molecules have weaker intermolecular forces, and so will require less energy to break them apart and turn them into a gas. They have a lower boiling point. The longer molecules have greater intermolecular forces. More energy is required. A higher temperature will be needed to evaporate these molecules. They have a higher boiling point.
Okay, using the information you've seen in the video, I'd like you to answer the questions on the screen. So, the family of compounds found in crude oil is hydrocarbons, although there are some impurities of sulfur, and you will look at those impurities in a later topic. The two elements these compounds are made from are hydrogen and carbon only. So when you are talking about hydrocarbons, they are compounds that only consist of those two elements. Describe and explain how the boiling point of these molecules changes as the length of the chain increases. The larger the molecule, the higher its boiling point, and it's because there are stronger intermolecular forces. Little bit of a link there to bonding. We will look at this again later on in the video. So, just a little recap from atomic structure. You may already be sussing out that this does link a lot of the concepts we've learned about so far together. I'd like you to draw the electronic configuration of carbon and hydrogen. And when you've done that, if you still have time, I'd like you to tell me how many bonds each of those elements would form. So you should have that carbon has 2 electrons in its first shell and then 4 in the outer shell. And then you should also have that hydrogen has 1 electron. Now, using what I said on the last slide, these elements will bond to fill that outer shell, which means carbon will form 4 bonds because it needs 4 electrons to fill that shell. And hydrogen will form 1 bond as it requires 1 electron to fill that shell. Now this is important when we are drawing these molecules because we need to always make sure that our carbons have 4 bonds and our hydrogens have 1. The hydrocarbons found in crude oil are called alkanes. They are saturated, so they only have single bonds in their structure. Some would say they have all the single bonds and possibly sing it to the tune of a well-known song. However, I won't do that today. They have the general formula CnH2n plus 2. That means for every carbon in the molecule, there are 2 hydrogens plus an additional 2. Now, the first 4 alkanes have got the names as seen on the screen, but the important part is that we know why they have these names. Methane has 1 carbon. The purple part of the name is used by chemists to tell us the number of carbons in the molecule. So all molecules that start with meth will have 1 carbon in that molecule. The second alkane is ethane. It has 2 carbons. Propane has 3 carbons and butane has 4 carbons. Now those prefixes, meth, eth, prop, but, are the order in which we name our first 4 hydrocarbons. but like I said earlier, this is used in organic chemistry to name molecules that consist of that many carbons. As we are talking about alkanes today, the names all end in ane, and that is a characteristic. So if I say, oh, pentane, pent means 5, and ane means it is an alkane. Now, I have a little rhyme to help me remember this, and it's that many elephants poo big, meth f prop bute. And I'll keep reminding you of that through the topic. So I'm going to insert a video here that goes through the golden rules for drawing hydrocarbons. This is the order I always follow when I am drawing these. So the first thing is I will draw my carbons first, then I will join them into a chain. Then I will make sure every carbon has 4 bonds, and then I will add hydrogen onto the end of each of those bonds. But it's better if I just show you. Hi everyone, so I'm going to use the golden rules to draw a molecule of propane. So first, looking at the name, if it starts with prop, that means there's 3 carbons, and ane means that it's an alkane, so there will only be single bonds because it's saturated. So, rule 1, draw the carbons first. Rule 2, join them in a chain, and because it's an alkane, there will only be single bonds in that chain. Rule 3, make sure each carbon has 4 bonds, so it's good practice to count them. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Then I'll add a hydrogen onto the end of each of those bonds, which is not in use. So there's my molecule of propane. It'll have the formula C3H8. So now that you've seen that, I would like you to draw a molecule of butane. And if you have chance, could you also give us the chemical formula, please? So you should have had something that looks like this. Make sure that your bonds go from the middle of the carbon to the middle of the hydrogen so it's really clear. The chemical formula is C4H10. Right, let's have a go at another one. I'd like you to draw a molecule of methane. So you should have something that looks like this. Remember that meth means there is one carbon, and the formula is CH4. You may have put C1H4. We don't typically put the number in the chemical formula if there's only one atom, but that wouldn't be wrong. Okay? Right, let's have a go at one more. I'd like you to draw a molecule of ethane. So you should have something that looks like the image on the screen. And the chemical formula is C2H6. Now we have drawn some of these, it is time for us to start looking at the properties and how these link to chain length. The first property we are going to look at is boiling point, and this is really important because it determines how we separate these substances. Small hydrocarbons have a low boiling point, whereas large hydrocarbons have a high boiling point, which means that the boiling point increases as you increase the chain length of these molecules. This is because there is stronger forces between the larger molecules, so they are less easily overcome. The next property is flammability. Smaller hydrocarbons are very flammable, they have a high flammability, and large hydrocarbons are less flammable, which means flammability decreases as we increase the chain length. The last property we're going to look at is viscosity. Now, viscosity is how easily a substance will flow or pour. As you can see in the diagram on the screen, the first jar pours very easily, and as you go across, the jars pour less easily. The first jar would be an example of a small hydrocarbon. So that has a low viscosity, so it pours easily. Large hydrocarbons have a high viscosity, which means they do not pour as easily. And this is mainly due to the chains becoming entangled and not being able to move over each other as easily. Now what I'd like you to do is I'd like you to describe and explain how the boiling point changes as you increase the size of the hydrocarbon. Describe and explain how viscosity changes as you increase the size of the hydrocarbon, and how flammability changes as you increase the size of the hydrocarbon. Okay, so the boiling point increases as the size of the hydrocarbon increases because the forces between the molecules are stronger and more energy will be needed to overcome those forces. When we're talking about viscosity, as the size of the hydrocarbon increases, viscosity increases also because the molecules are larger and will become more entangled. And when we are describing flammability, as the size of the hydrocarbon increases, the flammability decreases. This is why smaller chain hydrocarbons are better as fuels. Now we're going to read through an exam question and then I'll give you some time to have a go at it. A student investigated the viscosity of liquid hydrocarbons. A viscous liquid is a liquid that flows slowly. The student used this method. They measured out 50 centimetres cubed of the liquid hydrocarbon, poured the liquid hydrocarbon into the funnel, and timed how long it took for all of the liquid hydrocarbon to run out of the funnel. They then repeated this for other liquids. The first question is they would like you to name apparatus A in the figure and also name the apparatus that could be used to measure out 50 centimetres cubed of liquid hydrocarbon. Okay, so our next question. So we have a table of results on the screen. The student did the experiment 3 times with each liquid hydrocarbon. I'd like you to give 2 reasons why. And then use the data to calculate the mean time in seconds for C7H16. Then I'd like you to complete the sentence. Okay, last few questions. So a ring has been drawn around one of the results in the table. The result was not included in the mean. Could you suggest why? And suggest one error that the student may have made to get the ringed result. Okay, so a student investigated the effect of temperature on the viscosity. The liquid hydrocarbon he was using used the hazard symbol shown below. Suggest why the student warmed the liquid hydrocarbon using warm water and not a Bunsen flame. And the student wore safety glasses. Give one other safety precaution the student should take and give a reason for this safety precaution. So the mark scheme is on the screen for the first few questions. The equipment was a conical flask, and you would use a measuring cylinder, pipette or burette to measure the volume of a liquid. Then you would repeat so anomalous results could be ignored, and so you'd calculate a mean to improve accuracy. So you could phrase that as a more accurate mean, and then you would get both marking points. The mean was 19, and the completion of the sentence was increases. The result was circled because it's anomalous. The reason for it being anomalous is they've either used a shorter hydrocarbon, they used a smaller volume, they started the timing late, or they stopped too early. It has to be a reason that made that result too small. The substance was flammable, which is why they warmed using hot water. And the safety precaution has to be a suitable safety precaution. So it has to be something like wearing gloves, because it's an irritant, as was seen in the hazard labels, and do not pour down the sink because it was harmful to the environment, or there was a picture of a dead fish on it, so you could say that it kills fish. That's everything for this video, and I will see you soon.